Perfect. Okay. Now I've shared my screen again. Yeah, now you will be able to see it. Okay. So just for the sake of completeness, I would like to explain the topic which I missed, right? Because it could be that Zahib is not familiar with these topics. So it's important to cover all the topics. Okay, it's a very simple topic. Let me just make it a bit more readable. Yeah, now it's readable. Okay. So the laws of exponents. Any base to the 0 power equals 1. Okay, so if we have 80 to the 0, if we have 12xy to the 0, any number that has 0 as its exponent has the answer 1. Whenever we have 0 in the power, the answer is 1. Okay, even if it's a big number, if we have 0 in its power, the answer is going to be 1. When multiplying identical bases, keep the same base and add the exponents. This was the rule which we used in the previous practice question. So we have two numbers, the bases are same, and the powers are being added in this case. Okay. So bases are same, b to the m into b to the n. Here bases are same. When bases are same, powers would be added, the exponents would be added. So b to the m plus n. Let's talk about these examples now. So we have n to the 5 into 9 to the 6. Now in this case, the bases are same, right? And the powers would be added. So this would be 9 to the 11 simply. And again, bases are same. So a to the 2 plus 3 plus 5, the answer is a to the 10, right? Is it clear?
Yes.
Okay. But now we're talking about division. When dividing identical bases, keep the same base and subtract the exponents. B to the m divided by b to the n means this is the division sign, b to the m is here and b to the n is here. Okay, be clear with the order in case of division. So the answer would be the base would come as it is and the exponents would be subtracted, m minus n. And again, if we have b to the m divided by b to the n, the answer would be the base would come as it is and the powers would be subtracted, right? This is how you solve a question when we have division. The powers or the exponents are subtracted in case of division, and in case of addition, they are added, multiplication, they are added. We have this 6 to the 5 minus 3. Why? Because we had 6 to the 5 divided by 6 to the 3. So the answer is 6 square. Let's talk about this one again. We have a to the 9 and a to the 4. They're being divided. The bases are same. The base is a in both the cases. So we have base and we have subtracted the powers. Okay. If an exponent appears outside of the parenthesis, multiplying any exponents inside the parenthesis by the exponent outside the parenthesis. Okay, so we had this as one of the options. So when we have b to the m, this is n, the answer would be b m cross n. In this case, the powers would be multiplied. Okay, in such a situation when we have exponent inside the bracket as well as outside the bracket, so simply these m and n would be multiplied. Now we have this example. So this is 4 to the 3, 8. They would simply be multiplied. So this would be 4 into 24. Okay. And what are we going to do in this case? This is a bit different. Just give me a second. I have to connect it. Yeah, can you hear me?
Yes, ma'am.
Okay, right. So in this case, we have two numbers, j to the 4 into k to the square. We cannot simplify j to the 4 into k to the square because bases are different. We cannot add the powers, but we have this 3 over here. So it would be multiplied with both these 4 and 2. Okay, so we would have j 4 into 3 and k 2 into 3. So the answer would be j 12 into k 6. Okay, so this is something which you already knew, but just for the sake of completeness, I had to explain this topic as well, just so we know every topic as well as we practice all the questions. And we would still have enough time at the end to, solve past paper questions. Don't worry about that. Okay. Now we have to discuss the ninth topic. Okay. Squares and square roots. The square of a number is the product of a number and itself, right? For example, the 25 is the square of the number 5 because 5 into 5 is 25. The square of a number is represented by the number raised to the power 2. This is something which we already know. A square is basically square of A, right? So 5 square is basically 25 and 25 is basically square of 5. And the square root of a number is one of the equal factors whose product is the square. For example, 5 is the square root of the number 25 because 5 into 5 is 25. The symbol for square root is this one. The symbol is radical. The number inside of this radical is called radicate. Okay, the definitions are very complicated. The concept is very simple. Okay, 5 square is 25. 25 is the square of 5, and square root of a number, this is square of 5, and 5 equals under root 25. This is the square root of 25. So this is basically the radical, this is the radicand, and this is what they have tried to explain in such complicated words. Okay, is it clear? Do you want to ask me something? You can, okay?
No, ma'am, I understand.
Okay. The topics would get complicated once we're done with these simple topics. Okay, perfect squares. The square root of a number might not be a whole number. For example, there's not a whole number that can be multiplied by itself to equal 8, right? We don't have a number such that when we multiply it by itself, or if we find the square of that number, we get a whole number, or we get 8, right? So such numbers are not perfect squares. Like 8 is not a perfect square because under root 8 is not a whole number. The only thing to remember is 8 is not a perfect square because under root 8 is not a whole number. Okay, this is a number in decimals. So this is not a perfect square. These are the examples of perfect squares. What is a perfect square? Because 1 square is 1. 4 is a perfect square because 2 square is 4. 9 is a perfect square because 3 square is 9. 16 because 4 square is 16, and so on. Okay, so we know a list of perfect squares really well. We can start off by doing 1 square, 2 square, 3 square, and so on. So we would have all the perfect squares. Okay, and the rest of the numbers would be imperfect squares, or they would not be perfect squares. Okay, is it clear?
Yes, ma'am.
Okay. Right. This is a very interesting yet important topic. Properties of square root radicals. The product of the square roots, two square roots of two numbers is same as the square root of their product. Okay, what they are trying to say is if we have two square roots of two numbers, this is same as if we multiply these two numbers and then find out their square root. Okay, that is under root 7 into under root 3. The answer would be same as under root 7 into 3. Okay, so this is the first property, right? Okay, the quotient of the square roots of the two numbers is the square root of the quotient of the two numbers. Okay, by quotient, they mean when we are dividing two square roots, this is the situation. It's just like multiplication. Under root a divided by under root b is basically under root a by b. And obviously, b is not 0. Just don't get confused by the statement, because whenever we have 0 in the denominator, it is something that cannot be defined. Okay, so this is a given. So in this case, just remember, whenever we have under root a divided by under root b, the answer is going to be same as under root a by b. Okay, this is an example. Under root 24 divided by under root 8, this is same as under root 24 by 8, that is under root 3. Okay, is it clear?
Yes, ma'am.
The square of a square root radical is the radicand. Okay, so what is the radicand in this case? What is the radicand in this case?
And
Excellent. So they are saying whenever we find out the square, whenever we square the square of a square root radical, the square of the square root radical, this under root thing is basically the radicand. Okay, under root n whole square is n, because this 2 and this under root can be cancelled, because the power of this radical is basically 1 by 2. So when I'm saying I'm squaring it up, I'm basically saying that, we have just learned the concept of exponents. This would be like this, and this would be x. This is why we are having this x. Okay, right. This is again an example. When adding or subtracting radicals, now we are adding radicals with the same radicand. Okay, in this case, we are adding two radicals, and this is same. B is same. The radicand is same. Add or subtract only the coefficients and keep the radicand same. Simple. So we have two numbers which are being added. These two numbers are two radicals, and the radicand is b, that is same in both the cases. So we simply have to add these numbers, these a and this a and c, and we'll write down the radical as it is. Okay. Again, this is an example. The radicand is same. Under root 7 would come as it is, but 4 plus 6 would be added, and this is same. Okay, is it clear?
yes, ma'am.
Okay. You cannot combine radicals with the different radicands using addition or subtraction. We could have done this in case of multiplication, just like we did over here. But be very clear, this rule was for multiplication and division. When we are adding two radicals, you can never ever simply just say that, okay, under root a plus under root b is under root a plus b. No, it is not the case. Okay, under root 2 plus under root 3 is not under root 5. Okay, this is what we used to do in multiplication and division. Things are different in case of addition and subtraction. To simplify a square root radical, write the radicand as the product of the two factors, with one number being the largest perfect square root. Then write the radical over each factor and simplify. Okay, we have under root 8 and we have to simplify it. Okay, but under root 8 is not a perfect square. We have just discussed that. But if I break down under root 8 into factors, I need to think of a factor that is a perfect square. So when I have 8 as a radicand, I know that I can write down 8 like this, 4 into 2. Now we have to use this rule, and I can write it down as under root 4 into under root 8 2, and under root 4 is basically under root 2 square into under root 2, because 4 is a perfect square. This would be 2 and this is under root 2. Okay, so this is what this complicated statement means. Whenever you have a number of this sort or of this sort and they ask you to simplify it, you simply need to write down this 27 as the product of its factors, and you need to think of the biggest perfect square. 9 is a perfect square, so under root 9 would be 3. And so the answer would be 3 under root 3. Okay, is it clear?
Ma'am, I don't understand this.
Did this one?
Yeah, this point.
Okay, okay, I'll explain it again. No problem. Wait, okay. Let me just change the color. Okay. To simplify a square root radical, this is the question. Okay, you have been asked to simplify this. Write the radicand as the product of two factors. You have been asked to simplify this 8 under root 8. You have to write down the radicand, that is 8, as a product of two factors, such that with one number being the largest perfect square root. If you start factorizing 8, you could have written this as well, 2 into 2 into 2. But rule number 1 is that you need to write it as a product of two factors only. Okay? So by two factors, when it's 8, the only options are 4 into 8, with one number being the largest perfect square. In case of 4 and 2, 4 was the largest perfect square. And why do we need this largest perfect square? We need this perfect square just so we can get this 2, just so we can simplify this under root 8. Okay, this 2 under root 2 is basically a simplification of this 8. Then write the radical over each factor and simplify. Right, so we had this under root 8. We have written under root 8 as product of two factors like this. One number is the perfect square. This 4 is the perfect square. Now I need to write down the radical. They're talking about this radical, basically. This radical and this radical, right? And we have to simplify it. Since one of the numbers in the product was a perfect square, so this is a given that I would be able to simplify one of these numbers. Okay, let's talk about this example. I have under root 27. Now, if I start factorizing 27, I know it can be 1 is a factor, okay, 3 is a factor, all right, 4 is not a factor, 5 is not a factor, 6 is not a factor, 7 is not a factor, 8 is not a factor, 9 is a factor, okay. So either I could have written it this way, 3 into 3 into 3, or 9 into 3. And this is what I have to do, because they said that I need to write it down as a product of two factors, okay, not three factors. So this is what we had to do. Now we have to use this property and write it down like this: 9 into under root 3. This 9 is a perfect square, so I can simplify this. This is 3 square into under root 3. This 2 and under root can be cut, and the answer would be 3 under root 3. Is it clear now? I can explain it to you with some other examples as well.
No, ma'am, I got it.
Excellent. Perfect. Okay. Let's do some practice questions now. Is it readable? Sorry. Right. So this is we have three practice questions here. Which of the following is equivalent to under root 196? Now they are not going to ask you this question in the calculator part. Obviously, they'll ask you in the non-calculator part. Okay, and to solve this, you cannot start. You don't have to, find 3 square and then 14 square, and obviously you need to. But we know we have been used to solving 15 square in different examples, right? So you can just pick up, or even if you don't know, just pick up one random number. Let's say I pick up 15 and I find out its square. I'll multiply it, and obviously that would take time, but it is going to give us a direction. Okay, so 15 square is 225. Now this 225 is telling us that either 13 is the answer or 14 is the answer. Okay. Now we will solve it for 13 square, and when we multiply 13 into 13, the answer is 169. Now simply we can just say 14 is the answer. We don't have to solve it, okay? Because they are not going to give this question in the calculator part. They would give you in the non-calculator part. You need to know some time saving tips, okay? It's 196. Just pick a number randomly. Let's say 15. The answer was 225. Now this is very obvious that 15 square, the number would either be 14 or it would be 13. Okay, is it clear?
Yes.
Are you sure?
Yes, ma'am.
Okay. Which of the following is a perfect square? Again, you cannot start, guessing random numbers and think 7 into 8. No, it is not. 78, no, it is not. 80, no, it is not. 81, yes, it is. Okay, in this case, I'm doing it randomly. Why? Because I know 1 is a perfect square, then 2 square, 4 is a perfect square, then 9 is a perfect square, then 16, then we have 25, then we have 36, and so on. Okay, this is a list of perfect squares which anyone can write down by simply doing 1 into 1, 2 into 2, 3 into 3, 4 into 4, 5 into 5, 6 into 6, so on and so forth. I'll end up getting 81. Okay, 9 square is 81. Right, is it clear?
Yes, ma'am.
Okay, which of the following is equivalent to 2 under root 6? Okay, now this is an interesting question, and this is from what we have just discussed. Okay, so I want you to answer this. So can A be the answer? Right, so we know that 2 would come as it
Mm,
is, but sorry.
I don't think A is the answer.
Yeah, okay. 2 can be written as it is, and under root 6 can be under root 2 into 2 into under root 3. So this cannot be the answer. Right, okay. What about this under root 24? So as per the rule which we have just discussed, the rule said that we can simply, just give me a second, something has happened to my writing tablet. Okay. So we have just discussed this rule under root 24. We need to write it down as a product of two numbers. So the two numbers are 6 into 4, and this is under root 6, and this is under root 4, and under root 6 into under root 2 square. These two can be cancelled, so 2 under root 6. So this is the answer, okay? Is it clear now? Is this concept clear now? I cannot hear you.
Can you hear me?
Yeah, I can hear you now. Is it clear?
Yes.
Okay, perfect. Let's talk about the last topic now. Okay, this is the let's see if this would be the last topic or we would be able to solve another question. Okay, negative exponents. Negative exponents are the opposite of positive exponents. Therefore, because positive exponents tell you how many of the base to multiply together, negative exponents tell you how many of the base to divide. Okay, this definition is very confusing. Basically, when we had a to the n, this was telling us that we'll be multiplying a n times to get this a to the n, right? We were multiplying this. And this a to the minus n is telling us that we will be dividing a n times by 1 to get this a to the minus n. So this is the difference. When we had positive exponent, we were writing it as product. When we have negative exponents, we are again writing it as a product, but the only difference is that here a is in the denominator. Okay, is it clear?
Yes.
Okay, so we have 3 minus 2. 3 minus 2 is basically 1 by 3 square. This 3 square is 3 into 3, and this is 1 by 9, right? And if I talk about this number, minus 5 minus 3, minus would come as it is 5 to the cube minus 1, 5 into 5 into 5, and this is basically minus 125. So the only learning point in this case was that whenever we have negative exponent or negative power, this thing can be written as 1 over the same thing with positive exponent. Okay, rest we know how to break down these factors, how to solve them. Okay, let's just look into this practice question. Which of the following is equivalent to minus 6 to the minus 4? Okay, so we are sure of the fact that the answer is going to have a negative sign and it is going to be a fraction. The answer would be minus 1 over 6 to the 4. So this cannot be the answer because it is positive. This cannot be the answer because it is positive. And this cannot be the answer because it is not a fraction, right? So either this is the answer or this is the answer, right? And definitely this is the answer because it would be of this form 1 over 6 to the 4. Okay, so this is not going to be of this form. So this is the answer. Now here we have not wasted our time on multiplying 6 4 times. 6 into 6 into 6. We have not done that since we were clever enough to know that the answer would either be negative or it would be a fraction. So we simply cancelled out and the only option left was the C. So this is the answer. Okay, and this is how you need to do questions in case of SAT. Okay. Is it clear? Okay, I guess it's clear because I am not able to hear you. Okay, right. So now we have rational exponents. I think it's still very small. Let me make it more readable. We have discussed positive exponents and we have talked about the negative ones. But now we will see the case when we have rational exponents. Okay. So rational numbers are numbers that can be written as fractions, decimals, repeating decimals. We have discussed this. Similarly, numbers raised to a rational exponent are numbers raised to fractional powers. Okay. When we say rational exponents, it would be basically a number with a power that is a fraction. A number with a fraction as a power, okay? 8 to the 1 by 3. 8 is the base, 1 by 3 is an exponent. Since this 1 by 3 is a fraction, so it is a rational exponent, okay? First, you need to know what a rational exponent is, right? Okay. For a number with a fractional exponent, the numerator of the number tells you the power to raise the number to, and the denominator of the exponent tells you the root you take. Okay, we have 4 1 by 2, right? 4 is the base. This 1 is telling us that we only have this 4, so we have to write this 4 once only. We are not going to multiply it with another 4. And this 2 is basically telling us that this is going to be the square root. So this is the answer. Okay, you'll understand this. Let's move on to the third one. 8 1 by 3. We have 1 in the numerator. So 8 would come as it is. We are not going to multiply it with any other number. And this is not a square root, it is a cube root because of this 1 by 3. So this can be simplified easily. 8 is 2 cube and this can be cancelled. So the answer is 2. Is it understood? Is it clear?
Yes, ma'am.
Okay. Now let's talk about this. This is what they have written for the previous example. 3 2 to the 3. 3 is the base. This is the base. And this is the exponent. So 3 square. Square is in the numerator. So it means 3 would be multiplied with 3 and this cube is basically telling us that it is going to be the cube root. So exponent is a fraction. Exponent is a fraction of this form. This a would tell us how many times we have to write down this number, and this b would tell us that if it's either a square root, cube root, or if it's something of this form. If we have 4 over here, it would be a quadratic root, right? Okay, so the answer in this case is under root 3 to the 9. This cannot be simplified further without calculator, okay? Okay, let's practice try out this question. Which of the following is equivalent to 8 2 to the 3? Now 8 is the base, this is the exponent, and this basically means that we will be having a cube root. This 1 by 3, this 3 in the denominator is telling us this is a cube root, and we would have 8, and this 2 is telling us 8 square, right? Because another way of writing it down could be this, and this is basically 8 2 to the 3. Okay, this is the underlying concept. Okay, so we have this cube root, and 8 square is 64. So this is the answer, right? Okay, so is it clear? Okay, so we are done with today's session. In case of any ambiguities, you can ask me right now or on that group as well, or you can also message me privately. And if you are practicing SAT questions, you find anything difficult, you get across a question which you are not being able to understand, or even though you understand it, but your method of solving is too time taking, you can simply message me on WhatsApp or call me directly. I'll tell you there and then, because I know that it's really frustrating when you are solving a question and it's taking lots of time, because these SAT exams are very important for you. Okay, you plan on going to Canada, maybe this is what you told me.
Yes.
Yeah, so these and are you done with your IELTS exam?
No.
So would you be giving IELTS?
Well, I heard that IELTS is only required if you don't get a good grade in your O
O
levels
levels,
English.
yeah,
So
exactly. So you, yeah, so you're
I got an A star, so I don't think I need
excellent.
to give it.
Okay, perfect. Yeah, in that case, it's not needed. But I also plan on doing my MSc in maths from Germany. So although my English grade was an A as well, but the problem is that the German embassy requires an IELTS exam. So in that case, I had to give IELTS. Anyways, we are done with today's session. So I'll see you tomorrow. Let's see if Sahib would be part of that session as well. And yeah, that's it from my side. I repeat, if you get across a question which you are not being able to understand easily, you can just message me on WhatsApp. Okay, you can either send me a snapshot or a picture or anything. I'll explain it to you there and then. Okay,
Okay, ma'am. Thank you so much.
you're welcome. Take care. Allah Hafiz.
Love.